Hey you guys, so today we're going to start chapter 2 about periodic functions and symmetry. This is going to be the intro lesson for us to start to be able to graph trig functions. So before we get started, I just want to define some terms that we're going to need to know. The first one is periodic, okay? That just means that the graph repeats in cycles. Okay. The next thing that I want to talk about is symmetric to a line. Basically, if you can fold the graph on a line and then both sides match, then that means the graph is symmetric to a line. Okay, in a little bit we're going to do symmetric about the y-axis, so the y-axis will be your line. Okay, symmetric to a point basically means you can rotate the graph 180 degrees, and then the graph still looks the same. Okay, and symmetric to a point means in a second we're going to be talking about something being symmetric to the origin. Okay. The next definition I want you to know is period. And this is how long it takes the graph to complete one cycle. We're going to be talking about that periodic term and period here in just a second. Okay, the last two things is even and odd functions. Okay, an even function is symmetric to the y-axis. And I want you to think about it like this. I'm going to use the easy function y equals x squared, quadratic. Okay. The first part's kind of easy. If I plug in a 0, I get a 0. But if I plug in a 1, 1 squared's 1. But what happens when I plug in that negative 1? I also get a 1. Okay. What if I plug in a 2? I get a 4. If I plug in a negative 2, I still get a 4. Okay. And then if you look, even though I'm a little off, if I was to fold that on top of the y-axis, then my graph would line up together. So that's why an even function is symmetric about the y-axis. So a way that you can remember this is if I have my positive x's, but if I plug in my negative x's, I still get my answer that I would have gotten for my positive x's. Okay. Odd function is going to be symmetric to the origin. Okay. So for this one, I'm going to show the cubic function. Okay, so of course if I plug in a 0, I get a 0. 0 cubed is 0. 1 cubed is 1 cubed. But then if I plug in a negative 1, I get a negative 1. Okay. If I plug in a 2, I get an 8. If I plug in a negative 2, I get a negative 8. Okay. So basically the reason why this is symmetric about the origin is that these are coming across and through the origin to the other side. And if I was to also rotate it 180 degrees, it would be right on top of each other. So for this one, I want you to memorize that if I plug in negative x's, I will get the negative version of my positive x's, and that's exactly what happened when I graphed this. Okay, so now let's start some examples. Okay, so what I would do here is really quick, just go ahead and pause the video and copy down the graph. Okay, so you should have paused the video and copied down the graph. So let me explain to you what's going on. I'm telling you that the period is 2. That means one cycle has a length of 2. So if you look right here, okay, the graph starts here. I come down, I come back up. It took me a length of 2 to get there. So what I am asking you to do is I'm asking you to extend the graph to 8. So I want you to go 5, 6, 7, 8. And then I want you to repeat the graph. So I want you to go down at the 3, so down like that, and then back up at the 4, and I just completed that in a period of 2, another cycle. So then you're going to do the same thing at 5, and then just keep going. Okay, so basically what you're doing is you are continuing the pattern. Okay, so I want you to do the same thing here. I want you to pause the video, copy down what it is. Okay, so I got to extend my graph, so 2, 3, backwards to a -2. It tells me that it takes a period of 1 to complete a cycle. So if you look here, was that a period of 1? Yes, it was. So I want you to continue the pattern backwards and then forward. And there you just completed the graph. Okay. Okay, so I'm going to skip the next couple examples. I want to go to these examples right here. So I know it's a repeat of examples, but these were some things that I added in at the very end. So what I want you to do is copy these down. Okay, you're more welcome to pause the video right now and copy down example 1 and example 2 so you can be ready. Okay, now that you've copied them down, let's ask some questions. Do you think this first one is a function? Well, if I do the vertical line test, it'll pass. So yes, this is a function. The next question is asking you if it's periodic. Basically, does it repeat? And if you look at the graph, it's up, down, up, down, up, down. So yes, it's periodic. And if so, it's asking for the period. So how long does it take to repeat? So I like starting at 0. 0's right here. So I follow my graph down, I follow my graph back up, and if I was to go back down, that would be another cycle. So how long did it take for me to go from here to here? 2. So my period is 2. Okay, so if you look at example 2, same question would be, do you think it's a function? Yep, it only touches it once. Do you think it's periodic? Does it repeat? And nope, there's nothing about this graph that repeats, so you don't have to worry about finding the period. So here is example 3. If you want to go ahead and pause the video to copy it. Okay, so you should have copied this down. Is it a function? Yes, it is. Okay, is it periodic? Does it repeat? Does it go up, down, up, down, up, down? Yes, it does. How long does it take for it to repeat? So if I start at 0, I go up, and then I go back down here at 0. So how long did it take me to go from 0 until it started to repeat? That would be a period of 4. Okay, So we're going to go backwards to my other example that I wanted to do, which is these three right here. You have to determine whether or not it's even or odd. Sorry, I got happy with my D's. So therefore, if you want to go ahead and copy all three of them down, you can. You can pause the video now. If not, let's just go ahead and get started. So what you would have to do is this to figure out if it's even or odd. I want you to plug in negative x. So on this first one, we're going to go 2 negative x squared. So I don't know what x is, but if I plug in a negative and I square it, what's it going to turn out to be? Yeah, you guessed it. It's positive. So I have negative 2, sorry, I didn't mean to throw the negative in there. So I have 2x squared. This one and this one matches. So that means this is an even function. Okay. So I want to do C next. I want us to plug in negative x's. So a negative cubed is negative. A positive and a negative make a negative. Did every single sign change? I went from a positive to a negative, positive to a negative. So everything changed. So this one is an example of an odd function. You can also think about it like this, taking the negative out. And if I factored out a negative, I would get my original positive function. Okay, that's odd. If you do not get one of those, then it should be a neither. So let's see what happens on B. If I plug in a negative x here, and then plus 5. A negative x squared is a positive. 2 negatives make a positive, and then plus 5. Did every single sign change or stay the same? No. So let's look. This one stayed the same. This one stayed the same. But the one in the middle did not stay the same. It changed. So because we have a mixture of things changing and not changing, this one is neither. Okay. So I know I went kind of quick through this. Just copy some of the notes, see what you can do in the homework, and then be ready to have your questions for me on Thursday.